Share screen. Okay, now we're ready to go over the quiz. I got the 5 problems loaded up on Python Tutor. Like normal, you should double check and make sure that I have the correct problem up here. Because unlike computers, I am fallible and make mistakes. So this is the problem number 1. And these first 2 problems I think were the most complicated. This first one in particular I think is the most complicated. And so start off, create our x variable equal to 5 over here. Anytime we hit a function definition, we don't actually execute the function. We skip over to the very next line. It created this foo variable down here, which is a function object, but it doesn't actually call the function. It doesn't do anything. And now we have this for loop, for I in range 3. This I variable is going to get created, and it's going to have the values 0, 1, and 2. We start at 0, go up to, not including the value inside of range right here. So 0, 1, and 2. The very first time is 0. Foo, right here, this is a function invocation or calling the function. We know that because it has parentheses next to a word over here. The parentheses mean calling the function, and everything inside the parentheses is a parameter or an argument or a value being passed to the function. And so this I value right here, which is equal to 0, is going to be substituted in for this particular x value up there. I press next, and now we have this second frame down here. That's the foo function frame. And inside of there is x is equal to 0 because x was set equal to the I value right here. Press next again. We create that. One more time, create that res variable. It starts off as 0. Now I in range of, in this case, x is 0. We go up, start at 0 up to not including whatever's inside the range. So up to not including 0, which means we don't do anything. And skip over the for loop, return result, return 0. And so anytime you have this return value from a function, it gets essentially copy pasted right here where the function call was. And now we have x plus equals that function call. Well, the return value is 0, so when we come back here, we're just adding 0, and x stays the same. We had x plus equals 0, and so x stayed equal to 5 on that first round through the for loop. Now, on the second round through the for loop, I is going to change from 0 up to 1. There we go. I changed to 1 right here. Now we're inside the body of the for loop. This is called the body of the loop. And again, we have another function, invocation, function call. This time with I equals 1, I press next, x right here equal to 1. Coming back inside the function, this result res variable equal to 0. Now, when we do for I in range of x, x is equal to 1. So we are, in fact, going to go inside this for loop right here. We'll go inside of it exactly 1 time because the range is 1. We go start at 0, go up to not including 1, which means 0 is the only value. So this I value variable right here is equal to 0. Result plus equals that 0. And so result stays at 0. Return 0, return value down here is equal to 0. And so now, once again, x plus equals 0 down here. And so x stayed at the value of 5. Last time through the for loop, we have now I equals to 2. We know it's the last time because, again, the range is 3. We go up to not including the value 3. So this will be our last time through the for loop. For I evaluated at foo evaluated at x equals 2 right here. X is now equal to 2. Now we come down here. Now in this for loop, we're actually going to do something for I in range 2. First time through, I is equal to 0, so we don't add anything. Second time through, I is equal to 1. So we do, in fact, finally add something to this res variable right here. It's going to be equal to 1. And again, this is the last time through this inner for loop, the one inside the function, because x is 2. We go up to not including the 2, and so we'll skip over the body of the for loop and come down to this return res right here, returning the value of 1. Return value is 1. Now we copy and paste the 1 right here. We get x plus equals 1. So finally, we're going to modify this x variable, becomes 6. And now the for loop over here, again, it's the last time through. Range of 3 means up to, not including 3. We're currently at I equals 2, so we don't go and evaluate this body anymore. Come down, print x equals, and we get 6. A lot of work to add 1 to that x variable. Any questions on this first problem? The main difficulty of, I think, this problem is just there were so many steps in this problem, 31 steps. You had to just not make a mistake on any of those steps in order to get the correct answer. And in general, when programming and coding, that's usually what people find to be the hardest part, is just there's so many steps that you have to be evaluating in your head, and being able to do them all without making mistakes is very difficult. Problem number 2. Okay, another big one. Here, again, when we have the def foo, we don't call the foo function at this point. Instead, we skip over it, come down to line 10, creates this foo variable, but it doesn't evaluate anything. Now, when we do foo text equals foo of Guido, we're going to actually call the foo function with text equals Guido. Next, come up here. We know we're inside the foo function now because we have this frame over here that says foo at the top, and my text variable up here is equal to Guido. Press next. We're going to be using the accumulator pattern, so I've helpfully created this variable right here called accumulator. Next, and we're going to be looping over all of the characters in our string, all the characters in text. So the very first time we do that, C starts as the G inside of Guido. Here, one of the things we're testing is how do comparisons work on letters. Again, anytime you do a comparison on a letter, it compares the ASCII value of the letter if it's an English letter, or more generally, it compares the Unicode code point of that letter, which happens to agree with ASCII for all the English letters. So it's the same thing when they're both defined. But for English letters, as long as they're the same case, then everything is in alphabetical order. So here, C greater than or equal to A and C less than or equal to Z, this just means, is the letter that we got passed in, is it a lowercase letter? Anything else, this will evaluate to false, but anything that is a lowercase letter, this will evaluate to true. So this little g right here is a lowercase, so I press next, we go inside the body of the if statement down here. Now, the tricky thing right here is this new C equals char or C minus 32. Just so happens that this is the correct formula for converting a lowercase letter into an uppercase letter. And so when I press next, new C down here is the capital G instead of the lowercase g. And you could go to your ASCII charts, which I don't happen to have up, so I can't do it right now. But if you did that, you'd see that the number associated with the uppercase g is 32 less than the lowercase g. And that's the same for all of the different upper lowercase values.
So the ORD does the ASCII value as well?
ORD, yeah, so the question is, what exactly does ORD do? In general, ORD always gives you the code point of whatever the particular character is right here. If the particular character happens to be an English letter, happens to have a code point that is less than 127, then it will give you that ASCII value, that the ASCII and Unicode agree with each other when they're both defined. They agree with each other on the English language. It's only so this would not correctly convert to uppercase Greek letters, because Greek is in a totally different range of code points, and so you need a different formula here for Greek letters. But this if statement here is checking to see if something is a Latin letter or an English letter in lowercase, and so this formula right here happens to convert from lowercase English to uppercase English. And we also saw that there's like really, really weird things, like language-specific things, like in German, converting to lowercase and uppercase can change the number of letters, but that doesn't. So in general, for like to work with arbitrary languages, you need really complicated formulas, but for just English, this simple formula suffices. Did that answer your question?
Yes.
Good question. Any other questions so far? Okay, so we've calculated our uppercase G. We'll add it to our accumulator. Anytime we have a string, the accumulator pattern uses the plus equals instead of the append function. I press next here, and now I get the capital G in my accumulator variable. Keep walking through here, and each time the lowercase letter will be converted to an uppercase letter, and that uppercase letter will be appended to the accumulator. And so my lowercase Guido is going to, one at a time, become a fully uppercase Guido, like so. And then by the time I go through the entire text, everything happened to be a lowercase letter in this case. Everything happened to satisfy this particular condition right here. And so when I do the return accumulator, my return value is uppercase Guido. This thing right here is going to be replaced by my uppercase Guido. So foo text will be equal to the uppercase Guido, foo text, uppercase Guido. And that's what I'm going to print out. So uppercase Guido is the right answer. And whether you have strings or like quotation marks around it or not, I don't care about that. Just as long as you have those letters in uppercase, then you get the right answer here. We've mentioned before that Python has this built-in function upper, which can convert a string into an uppercase version of that string. And this is the implementation in Python for that uppercase function. For just the Latin letters. The actual one in Python has more cases like this for all the possible different languages. So it's very, very complicated. There's more than 10,000 languages that Python supports. And so there's a lot of different conditions like this, but they all look something like this. Any questions on problem number 2? Number 3. I think all these other ones are simpler than the first two, certainly shorter. So we create our 2 lists like this, XS and YS. It's important that they are 2 distinct lists. And then we're going to loop over each one of these lists individually. And the important thing about this is that, so we'll go X and XS. I'm not going over the indexes here. I'm not going over the indexes of XS. I'm going over the values of XS. So X is going to take the values 1, 3, and 5, ignoring the indexes of 0, 1, and 2. It'll take the values 1, 3, and 5. And we'll add the values 1, 3, and 5 to total each time, making total bigger and bigger. And another important thing is that this for loop for Y is not inside the for loop for X. So we're not going to do the for loop for Y until we're done with the for loop for X. So we'd say these are not nested for loops. These are sequential for loops, that they happen one after the other, not one inside the other. So we do everything for X, then we come down here and we're going to do everything for Y. This time subtracting all of the values of Y, and again it's the values down here and not the indices. And so run through, each time total is getting smaller and smaller. Eventually total gets to -3 and we print that out. -3 is the answer. Any questions on problem number 3? Problem number 4, more text. So here, create that variable. And really what this problem is testing is your ability to split and sort and slice and join. So a whole bunch of different string functions that you have to get them all correct what they're doing in order to understand what's going on. So here when I do XS equals text.split, that gives me this list of all of the words. The split function with a space inside of here can behave differently than the split function with no arguments. But in this case, they happen to behave the same. And so this is my result, my 3 words like that. Now I do the XS.sort. And again, this is one of the differences between strings and lists. In a string is immutable. There are no functions on strings that change the value of strings. But for lists, anytime you have one of these list functions, the list function is allowed to change the values. So this is going to actually change the values of XS right here. I'll press next, and you can see that they got reordered right here on this line. They got ordered not alphabetically, but ASCII-betically. And again, the capital letters come before the lowercase letters ASCII-betically. And so even though Guido alphabetically should become before Rossum alphabetically, we're going ASCII-betically, and so the uppercase R over here comes before the lowercase g in the sort. Now here on line 4, there's 2 things going on at once. The first is this slice XS at 1 to the end. So that's going to be these 2 positions right here, Guido and Van, ignoring Rossum. Rossum is going to get filtered out of the list here. We're not going to consider the word Rossum. And then I'm going to join them on this space right here. So it's going to just take Guido and Van and put a space between them and give me a string. And so that's what text is, Guido, Van. Press next, get to the end, and that's my final output. Guido, Van. And this time I spelled his name correctly. Any questions on problem number 4? Number 5, last one. Hopefully a simple one. Here we have 0x46. And this again is hexadecimal. This X standing for hexadecimal. The X standing for, again, the X of the hexadecimal. And so 046, you look it up in your ASCII table that I gave you, and you get that that is 70 in decimal. So we just print the number 70. Go ahead and total your points up out of 5 and somehow get your quizzes up to me. Do I have all the quizzes? I don't know what I said, but the quizzes. Okay. Administrative announcements. So again, this Friday no lab session because I will not be here. Also, because of fall break, we are not going to have a quiz next week at all. Since we don't have a Monday to go over stuff before the Wednesday, there just won't be a quiz on Wednesday, and your next quiz will be 2 weeks from now. The general policy again for quiz retakes is that you have until the next quiz to arrange a time with me to retake the previous quiz if you would like to do so. And you can do that once without any sort of penalty at all. Just whatever value you get on the retake will be what I enter into Sakai for you. So if for whatever reason you would like to retake this quiz, you have 2 weeks to do so until not next week, but the week after. Question? How many more quizzes do we have? Question is, how many quizzes are there in total? There's going to be a quiz every week, except there won't be one Thanksgiving. And so 5-ish. Yes.
What is the penalty that you talked about?
Oh yeah, the question is, what is the penalty on retaking a second quiz? Yeah, I haven't properly decided what that would be, but I'll go ahead and say that you can retake. So after the first retake, if you retake a second quiz, then the max that you can get on those subsequent retakes is a 3.5 out of 5. So whatever you get, it'll be the maximum of that and 3.5.
We get to retake it once.
So you can retake once and there will be no penalty, just that you can get up to 5 out of 5. But if you retake it a second time, then it's the max you could get on that particular quiz is 3 out of 5.
And if we do worse on the retake.
If you do worse on the retake, then it's whatever the retake value is gets entered into Sakai. So if disaster strikes and you get a 0 on the retake after getting a 5 on the original, and for whatever reason you decided to do that, I would be entering in a 0 into Sakai. Yes.
So the penalty is only on the second retake for one quiz, not 2 separate retakes on different quizzes.
You get 1 quiz retake throughout the semester without the penalty. Any subsequent retakes, even if it's your first retake of that particular quiz, has the penalty applied.
Okay.
So you only get 1 retake. Yeah. Yes.
If I'm not remembering correctly, was it the first? It was the first one.
And then the first 2 quizzes didn't have any, everybody was allowed to retake no matter what.
Right. So now after those 2, you get 1 retake.
Yes. Yeah. So the vast, vast majority of students still have your retake available to you. Good questions. Any other questions? Okay. So last time, where we left off, we were talking about you working with this sort of JSON type of file in Python. And our idea was that, or the example that we were using is that tweets are stored as JSON files. Twitter distributes these tweets as JSON files for people to do analysis on. And so if we want to load those tweets and do some analysis, then we have to know how to work with JSON files. And in general, JSON is a very popular format. And so working with data often requires you to know how to load and work with these JSON files. Before we get to the actual technical stuff, I'll just point out again down here, the first part of your lab for this week. Again, we don't have a lab session, but there will be still a lab assignment, is working on analyzing Trump's tweets, what we basically started in class. And there's this link right here that I'll just take us to, which talks a little bit about some like real world things that people have done with these tweets. Yeah, I mean, the president, obviously a very, people pay a lot of attention to his tweets, whether it's Trump kind of started it, but Biden now too. And so one of the things that people did was they wanted to know, like, was a tweet actually sent by Trump or was it sent by one of his staff members? And it turns out that in this JSON file, here we go, in this JSON file where, let's come down to the end, this JSON file that stores all of this tweet information, it has this source key inside of it. And it says, like, what is the actual name of the application that people use, that the person used in order to send this particular tweet. And so this tweet right here was sent from an iPhone. But if we do a Control F, look for, oh, that file doesn't have any Androids. This top file has a different one. This one, the source here says Twitter web client. So somebody just logged on to twitter.com and sent this tweet, as opposed to using like the built-in client for iPhone. And people looking at like the actual like pictures of Trump and his staff members noticed that Trump happened to have an Android phone and everybody else who was on his staff used an iPhone. And so you could tell that if something was sent by an iPhone, it was one of his staff members. And if somebody sent something from an Android from his account, it was actually from him. And so doing some interesting plots of that, you can see like over time, who was the most influential, who sends the most tweets from the Trump account. Well, it turns out like really early in the morning at like 5 a.m. Eastern time, where the White House is, it's usually Trump sending those tweets. But then in the evening or the afternoon, it's usually his staff members sending tweets in the afternoon. Or Down here, if we look at tweets that contain quotation marks inside of them, both Trump and staff members likely have a lot of these non-quoted tweets, but only Trump sends things with quotes. His staff members never quote things for whatever reason. Down here, if we look at whether there's a picture included or a link, Trump never includes pictures or links. He always just has his text, but his staff members, like 2/3 of the time, include pictures and links. If you want to see like what kind of words do people use, or do the, yeah, so this is sort of like the analysis we were doing, figuring out how many times. I think we were looking at the word Trump itself, but so here, I don't know, 50-ish times, and then Hillary, it's over 150 times. Trump 2016, basically as much as Hillary. If we want to look, here we go. So here's the ratio of which words are said for Android, so Trump saying it versus iPhone, not Trump saying it. Well, things like hashtags, apparently Trump doesn't like to use hashtags compared to his staff members. So Trump never used the hashtag Trump train. That was only his staff members. But Trump says things like badly, crazy, weak, spent, all those sorts of short, maybe strong-ish words that like people associate with Trump style speech. And so on. So this is the sort of interesting analysis that we're trying to prepare ourselves to do in Python. Question?
So does that mean that an application for iPhone versus the application for Android are just like two completely separate apps? They're not the same.
Yeah, that if whoever is sending the message is holding an iPhone while they're sending it, then over here, inside of this, that out the way, this very first field up here, it'll say Twitter for iPhone. But if it's like on a desktop, it's neither an iPhone or an Android, they just went to twitter.com, then it's web client. So back in 2009, like, I don't know, ancient times, everybody's still on desktops, I guess. Trump was using web clients, but by the time you get into like the election cycles for him and his presidency, then people are using either iPhones or Androids rather than the desktop to send it. All these files that we've been looking at are this condensed file that only has like 3 or 4 different, like the most interesting for most people sort of keys right here, like how many times was it retweeted, or what was the time it was sent at, the actual text of the tweet. If you look at the master underscore the year in that data set, the dictionary itself has like hundreds of keys, and it has all sorts of like crazy information inside of it, like the GPS coordinates that the tweet was sent from, that you might not think is contained in tweets, but all that information's there. Lots and lots of information. So what we're building up to, or what your next assignment is going to be, is to do something like what this web page is doing. It doesn't have to be as extensive as this, but you're going to be finding some data set that is interesting to you for whatever reason, and creating some plots of that data set. So this project 2 is posted, and again, by the end of today, we'll have covered everything that you need for this project 2. Question?
Well, in terms of the data itself, I know you saw all the condensed JSON files.
Mm-hmm.
Where do you find to download all of them? Someone's only downloaded one of them.
The question is, if you don't have all of these JSON files, where do you get them? And inside of there's a number of places where it's mentioned, but if you look inside this lab part1.py file, it has it in the instructions. Step 1, go to that spot and download all the files. Okay, so yes, our second project here is you're going to be forming some sort of data visualization like this of a data set of your choice, and you're going to create a web page that describes the results. You'll have until October 23rd to do it, so like 10 days or so. And the instructions here for this. So first, again, you have to find some data sets that's interesting to you. I have some links here that you're welcome to browse through to find interesting data sets, like from the UN or from the US government, or just this one here is things that data scientists in general have found to be cool. And so find something that's interesting to you and then make plots based on that. You'll have to generate 2 plots for this assignment. You'll have to find 2 data sets and generate 2 plots. They don't have to be related data sets, although it's I would encourage you to find 2 related data sets. So your plots are interesting, tell some sort of story. You can generate any kind of plot that you want, but you must have 2 different types of plots. So line, bar, scatter plot, whatever you would like. And there's this sample Matplotlib samples down here for you to browse and just see like what are the different types of plots that you might be able to do, and try to think about which ones are going to be the most cool for your particular data set. These bar plots like this and line plots are the simplest. So if you want to just have the most straightforward, easiest assignment, then do a line plot and a bar plot. But if you want to do something cooler like this, then I would encourage you to do that. There's a number of different like requirements here for the plots, but basically it comes down to the plots are somehow like reasonable looking, and I just can't list all of the things that make a plot unreasonable. But here is an example of a reasonable plot. I can actually like read the x-axis down here. Here's another example of a reasonable plot. I can actually read these values. Here's an example of an unacceptable, unreasonable plot because I can't read these things down here. And so I can imagine many, many different ways that you might make unreasonable plots. I can't list them all, but if it's somehow like actually conveying the information and I can look at it and figure out what the underlying data set is trying to say, then you'll get full credit on the plot. In order to submit this assignment, you're going to create your own another new GitHub repository for this project. So different than one that you created for your first web page. And again, you'll have to have 5 stars on that repo, probably from other students in the class. And in that repo, you'll have your image files, the Python files you use to generate the plots, any data files you need to generate the plots, and a markdown readme.md file that describes your project. So for this web page, instead of using HTML to generate the web page, your web page will be this readme.md file. You'll be using Markdown to generate it. And you'll see that that's going to be a whole lot simpler than that HTML you used on your first web page. You can just focus on the actual content. You don't have to do a whole bunch of weird formatting stuff. And then GitHub, with their internal Markdown compiler, which you now know how it works, is going to convert that Markdown file for you into an HTML file that other people can look at when you give them the URL. And so I have a handful of just basic requirements in the README so that I can look through it. Like you have headers that are somehow appropriate for your plots. And you're telling me a description about like why the plot is interesting, where the data comes from. But overall, you have a lot of flexibility on this assignment to do something cool. And as long as what you have is reasonable and I can understand the output, you're going to get full credit on the assignment. Any questions at a high level about what the assignment's asking? Okay, if as you're like working through it, you do come up with questions about like, I think what I've done is reasonable, but I'm not sure, do you think it's reasonable? Then that would be a great question to ask me like after class sometime or during a lab session or during office hours. And I will say, yes, you have full credit on the assignment right now, or no, make this change and then you'll have full credit. So if you want to 100% ensure that you have full credit, just show it to me beforehand and I will tell you whether you have full credit or not. Okay. So the next thing, or the last thing that we have to cover in order to do this, in order for you to do this assignment, is how to actually make these plots in Python. And we're going to be using a library called Matplotlib in order to do that. So we're coming back over here to our VS Code. And last time we were working on this notes_json.py file. This time we're going to work on this notes_matplotlib.py file. This file is also contained in the GitHub repository. So if you didn't download that last time, then download it now if you'd like to follow along with what we're doing. As people are working on that, I'll say that we will probably go back today in a couple before class ends and say some more things about this notes_json.py file. But to start with, we're just going to use this Matplotlib library. The basic idea of this file is at the top up here. I have some dictionary of the semantics of this dictionary is that the keys are words in Trump's tweets, and the values are the number of tweets with that word in it. Anytime I have a dictionary, I like to just have a comment that tells me like what are the keys and values of that dictionary, so that I know, so that I know what like the meaning of that dictionary is. The actual this particular dictionary itself right here is what you're generating in the lab for this week, part 1 of the lab for this week, and yeah, so if you get these results, then you've done the lab correctly. And again, this if we have time after we're done talking about this file, I'll finish up this notes.json file to complete this and basically be completing the lab. But in order to generate a plot in Python, the goal of my plot here, let's just go ahead and run it and see what the output's going to look like. When I run this, there we go. It's right now generating a bar plot where the x-axis is the keys of that dictionary. So these are the words that are contained in the tweets. And the y-axis is the number of tweets that contain those words. So a very common way for visualizing dictionaries is with one of these bar plots. And somehow every bar plot can be like defined or described by a dictionary. If I want to, there's a lot of ways, depending on your computer, to close out of the bar plot that gets displayed up here. But down here, what I'll do is I'll press Control-C, and that will end that program. Henry.
I know both Jackson and I are getting the error that import matplotlib.pyplot cannot be resolved.
Yeah, great question. So here, line 12, this is one of these libraries that does not come with Python that you have to install. And so the way that you get access to it is pip3 install matplotlib. And again, on my computer, pip3 is what I'll type here, but pip3 might be slightly different for you. Whatever you used to install YouTube download, whatever command that was, that's what you'll have to use to install Matplotlib. So something like this will install the program for you, will install this library for you, and then you'll have access to Matplotlib. Good question. Any other questions so far? I'll root that up.
Do you have to install it and then import it for every type of package that you?
Yeah, so the question is, anytime you're using one of these packages, one of these libraries, one of these things that somebody else has written inside of Python, you always have to do this pip install in the terminal down here. And then sometimes, depending on what that package is, if it's like YouTube download, then it gives you a new command you can use in the terminal down here to download stuff in that case. But every Python package will always give you new things up here that you can import, and then you'll have access to use. Vast majority of times, if you see somebody's code that it says like import something, in this case, it's something dot something else, but whatever the thing to the left of this dot is, that's probably what you want to pip install. Good questions. Any other questions so far? Yes.
After because I did just do pip3 install Matplotlib, and it said it installed, but it's still giving me like could not be resolved from source.
Yeah, if for whatever reason this is not working for you, this line here, then I'll need to look at your computer one-on-one. Probably what's happening is that you have multiple versions of Python installed, and so you'll need to use a different command than pip3 down here. And when you did YouTube download, you probably needed a different command down here as well. But I'll have to, yeah, there's lots and lots of different ways that this command can go wrong depending on your computer's settings. Anytime we're generating a plot in using this library, it's always going to be a very, very small number of lines to actually generate the plot. So in this case, it's just these 3 lines right here generates a bar plot. And there's not a single person in the world who knows like what the magic incantation is for making a bar plot off the top of their head. Even like the people who are the authors of Matplotlib, they don't know how to do this off the top of their head. Instead, they're always coming over here to sample plots, finding something that looks like what they think they want, and copying and pasting the code down here that actually generates that plot. The Matplotlib library itself, the number of lines of code inside of it is approximately 10 million lines of code, and so that's why nobody knows how it works. It's only the documentation that knows how it works. It's only Python that knows how it works, and people are just constantly relying on Google and looking up in the library how to actually do things. So in this class, we're going to see how to some different things we can do with this bar plot right here. But one of the things that we're not going to see is how to make any other type of plot. And in your project, your requirement is that you'll have 2 different types of plots. One of those types of plots can be a bar plot, and you can more or less copy what we've done in class. But the other type of plot must be something else, and we're not going to cover it in class at all. And so you'll have to go through this documentation on Matplotlib in order to figure out how to make that plot. And that's intentional because as programmers, we're doing this all the time. We're constantly just relying on documentation and Googling things. And so this is to get you some practice with that. Okay, so let's go ahead, let's run this again and remind ourselves what this looks like. There we go. And I'm gonna run this a couple times and we're gonna see that, yeah, different things happening. So here, what I want us to notice is that Trump here is in the very, very center right here. Kind of looks like, I don't know, somebody sticking their middle finger up at us. But I'm gonna close this program and rerun this program. So again, Control C will close it, up arrow, rerun the program. Haven't changed anything at all about the code, but now you see that the graph over here looks totally different. On the right over here, Control C to close it, up arrow to rerun it. And now the graph again looks different than it did before. The actual values associated with each of these words down here are the same, but the order that those words appear in is what's changing each time. Let's do it one more time. Down here, up arrow, rerun it. And again, a different order of things. What's happening is that in Python, actually any Python version, less than 3.8, the order, when you do the labdic.keys or labdic.values, when you get the keys or the values from a dictionary, again, the keys are these words, the values are these numbers, the thing to the right of the colon is the value, the thing to the left of the colon is the key. Anytime you get those keys and those values, they come in what is called a non-deterministic order. And that's sort of a fancy word for they're just random. You can't know what the order is going to be. If you have Python version greater than 3.8, then the order is going to be the order that they are actually added into the dictionary. But still, what's probably the best order, the order we would like, and the order that is reasonable for the purposes of the project, is alphabetical order. Like if I'm looking at a graph, I'm looking for a particular word, like I'm looking for the word Obama, then I want to know like roughly where in the graph I should be looking. And if things are alphabetical, then I know where to look. And so in order to make, like actually generating the plots is super, super easy. It's just copying and pasting these 3 lines of code and it'll generate the plots. The hard part anytime in Python we're doing data analysis is getting the like interesting things. This is the x-axis of the plot, the terms, the words associated with each bar. This is the y-axis of plot, the numbers associated with each bar. The hard part is actually coming up with these terms and these counts. The drawing of the plot, super easy. Just copy and paste these 4 lines of code. You're going to get a bar plot. But having a meaningful bar plot with the right terms and the right counts, that's where the hard stuff is. And so what we're going to talk about now is how can you get things in alphabetical order so that it's going to be a reasonable bar plot that is easy for people to look at and use. And there's a number of different strategies that we might try. The first one is just, so we have terms and counts. We might try sorting them. Something like that. Sorting them before we put them into the plot. Up arrow down here, rerun this. First problem here we get that is this attribute error. This dict keys has no attribute sort. I'm going to open up Python in interactive mode so we can see a little bit more what's going on. Anytime I'm running a Python script, a script is another word for a Python file. Anytime I'm running a Python script and I'm getting these some sort of error messages, going into interactive mode is a good tool for figuring out why I'm getting error messages. In order to get into interactive mode, again, I'll press the up arrow to get back to my previous command, and I'll press the left arrow so that the cursor is between the Python 3 and the file name that I'm running. And right here, I'll type the -i right here. That'll put me in interactive mode after Python opens this file. I know I'm in interactive mode because I have the 3 greater than signs down here instead of my normal prompt looking thing up here. Once I'm in interactive mode, I have access to all the things that were created by Python up to the point where it crashed. So if I type lab dict, that's the very first line of the file, I have access to that information. If I type terms right here, I have access to that information. And terms, it looks kind of like a list, kind of like these lists we've seen so far, but it's not exactly like a list. I can do a lot of things with terms that I might do with lists. Oh, that's not one of them. But one of the things that I can't do is sorting. If I want to convert terms into a list in order to be able to sort it, then the list function will convert it into a list. So it'll change it from this dict keys type into this list type, which I can then do my normal things that I like to do with lists. Yeah, so this isn't something that we've talked about at this point in class. Like, what exactly is this dict keys? Or if I type counts, what exactly is this dict values? If you take the follow-on class to CS40, CS46 is data structures. We'll talk about why this thing isn't, why this keys function doesn't return a list, and why this values doesn't return a list, why it has a special weird thing instead. But for our purposes now, the important thing is that we can convert them into lists just with this list function like that. And again, the list function takes this dict keys, which I can't do interesting things to. I can't, for example, sort it. But if I convert it to a list of terms like that, now it's a list. Like, make it a variable xs.sort. That's something that I am allowed to do. Totally okay. If this discussion about why I needed this list function up here doesn't 100% make sense to you, then that's okay. The key takeaway is that anytime, for the purposes of this class, for CS40, anytime you use the .keys or dot values. I'll put it on its own line. Convert the result to a list. And if you do that, then you can do all the, nothing bad will happen, but you'll get access to all the useful list functions that we've seen so far. More details in CS46 about why. Okay, so now that I've converted these things into a list, I know I can sort lists. So now I'll sort those things and hopefully everything will be now in a good order. I'm gonna press the triangle button up here again, triangle button, and it all runs now without error messages. And there we go, things are sorted in a nice looking order. Up here again. And once again, the things are in this deterministic order. So now the order is not going to change every time that I run things. The problem is my data is now incorrect. This is wrong. It changes the data in a bad way. And so let's see why that's the case. If we look up here at the dictionary file itself, Obama here has 2,700 tweets. Trump has 13,000. So Obama is the #2 topic that Trump tweeted about. If I run this, however, and look at the results, we'll see that Trump is the top result here, but my graph over here says that Russia is the second most popular thing for Trump to tweet about, and Obama is the third most popular thing for tweet about. So the data that's being displayed over here, it's in a nice order now, it's sorted, but it's wrong because this Russia value should be really small and this Obama value should be really big. Again, coming back to my dictionary over here, this Obama value should be really big compared to the Russia value. What's happening is that when I sort my terms, that's a great way to sort the x-axis, but when I sort the y-axis, I want this to be sorted the same way that this is sorted. I don't want the counts to be sorted numerically. I want them to be sorted the same way terms was sorted. And so what I'm going to do in order to make that happen is I'll use the accumulator pattern. Accumulator equals the empty list for term in terms. So I'll put this, what's the wrong thing is this counts.sort. This is the thing that's wrong. So comment that out. Accumulator equals the empty list. For term in terms, accumulator.append, and I want to append the particular count that corresponds to this particular term. So what was the name of the dictionary? It was called lab_dict. Lab_dict at position term. This will give me the number that's associated with that particular term. And now the accumulator will be in the same order. Like the counts will be in the same order as the terms are, like that. And down here, I'll say counts equals accumulator. If I save that, come down here, up arrow, rerun this. Now things are actually in the correct order down here, with Obama having a lot of tweets compared to Russia, Russia having relatively few tweets. So notice that the bars are no longer sorted like smallest to largest, but that's not what we wanted. We wanted the bars to be the right bar for each individual term. Any questions about? Yes. So the question is up here, would things still work if I took away this list function like that? And I save that, come down here, up arrow, rerun it. And yes, we're still going to get the same results like this. So that's not needed to do, but it's not wrong to do. So I'll say in this case, list function not needed, but it's also not wrong. And it's in fact never wrong to use the list function on the values or the keys. Good question. Any other questions? Yes.
I think this was earlier, but just with the values of kind of like the first comment was that at the top, sorry, it was like values.
Sorry, where should I go?
I think it's actually, yeah, so the beginning, like the first line. Yeah, values are the number of tweets with that word in it. So you're saying that I might have missed, is it like the dot values is what shows the number of words in it?
So here, anytime we have a dictionary, the thing to the left of the dictionary is a key. The thing to the left of the colon is a key. The thing to the right of the colon is a value. So the key here is the word Trump. The value is the number of times this particular word was inside of a tweet, or the number of tweets that contain this particular word. Did that answer your question?
Yeah. I'm confused on why the term stat sort and the count stat sort, like how did that manipulate the data to make it not?
Yeah, so let's
Or should I not worry about it?
no, this is a great question. The question is it's somehow like getting to the most important part of this entire assignment. Again, for the purposes of this assignment, of your project, creating the plots is trivial. You're going to take 4 lines of code, either these 4 lines of code to generate a bar plot, or 4 lines of code that you get from the internet to generate whatever other kind of plot that you're trying to do. Copy and paste it into your code, and you're done for generating the plot. The hard part is making sure that the data that you're passing into the function that generates the plot is correct. And so the question was somehow, why was what we were doing originally incorrect? And so I'm going to walk through the entire thought process again to because it's very easy to miss any one of these steps. So I'm going to start by, we'll comment out all the changes that I've made, commenting out all the changes that I made, and all that's left is the stuff that was originally in the file that we have, the lab dictionary. We're getting the terms, so we're getting the words over here from the dictionary, and we're getting the counts, the number of times each one of these words was actually sent. And then down here, we're plotting those in a bar plot. I'm passing terms and counts to bar. Terms is going to be the x-axis of that plot. Counts is going to be the y-axis. Let's run this, press the triangle button, and there we go. The first problem that we have is that these keys down here are not in a good order. On my particular version of Python, they're in a random order. And so every time I run this code, I get something different. Your version of Python is likely not to be random like this, but it's also not going to be in a nice alphabetical order, something that's useful, meaningful. And so the first thing that we were trying to fix is, how can I get these somehow into a meaningful, like alphabetical order? And our first hypothesis was, we know that we have a function sort, which sorts things. And so let's try that sorting function. Let's try it just sorting on the terms and not sorting on the counts. If we do this, run that, then down here, the terms are going to be in sorted order. Now it's all alphabetical down here. That's what we want. But the counts no longer match up with the individual terms. This really long plot right here, this really tall bar, this one should be associated with Trump. Because if we look at the actual raw data over here, let's make this smaller. If we look at the raw data in the dictionary up here, the word Trump has the biggest number. So the word Trump should have the biggest bar associated with it. This first problem is that I'm sorting the terms down here. I'm sorting the terms, but I'm not in any way sorting the values. And so the values stay in their original order. They still get plotted in whatever original order the dictionary happens to have them in, but the terms are going to be in alphabetical order. In order to somehow get the values into a sorted order, the first thing that you might think about doing is sorting the values, sorting the counts. This seems like a reasonable thing to do because it's what worked for the terms. This seems reasonable because it's what worked for the terms. Sorting the terms was what we wanted, so it seems like sorting the counts will also be what we want. If I do this, now the counts are in fact sorted. They go from lowest to highest. But this is still not the way that I want the counts to be sorted, because Russia right here, in this bar, Russia has a really tall bar right here, but Russia does not have a large number associated with it. The Russia number is 412, but the Obama number is 2,712. So the Obama plot right here should be large, and the Russia plot right here should be small. The sort function sorts these counts just numerically without considering that we don't want them sorted numerically. We want them sorted so that they stay in position associated with each one of their words. So this is wrong. It changes the data in a bad way because it sorts by the values, and what we really want is sorting by the terms. So this accumulator pattern right here, the purpose of this accumulator pattern was to give me the counts in the order of the terms. In order to get them in that order, so I start my accumulator at the empty list. I loop over the terms in the order that the terms are located in, and then I append to the accumulator whatever the particular value is for that particular term. Now this counts variable, which is equal to the accumulator, has these the values of my dictionary in the order that the terms are also inside of. So I'll save that down here, Control C, up arrow, run, come back over here, and now we can see that the Obama plot has a big bar right here and Russia has a small bar because, and that's what it should be, because Obama has a big number and Russia has a small number. Obama's number is 2,700, Russia's is 412.
So you said we're appending which aspect of the dictionary? We're appending to.
So down here, my counts, like the meaning of counts is the values of the dictionary. So in my accumulator pattern over here, I'm getting the values out of the dictionary and putting them into the accumulator. Again, anytime we have a bar plot, we somehow have a dictionary where the keys are the thing on the bottom and the values are the things being plotted. And if you want to plot them in the right sorted order, you have to sort the terms and then do some sort of accumulator to get the values in the same order that you sorted the terms by. And then you plot the thing like this. 100% of the time, the way students miss points on this assignment, and this is very common, probably historically about half the class misses points on this assignment, is because you just don't plot the actual data that you tell me you're plotting. That you plot things where the y-axis does not correspond in any way to the x-axis according to the data set that you have. So making sure that you do things like this, that you're actually visualizing the correct data is like the main purpose of this assignment. That is all we have time for today. Take it after class.
Sure.
Yeah, we'll you have all the things you need to know for the project, but yeah, happy to answer any other questions that people have after class.